Let's take a look at this question. We can see that the right-hand side, the value of r of x is not equal to 0, which means this is a second-order non-homogeneous differential equation. To find its solution, we're going to write it in its standard form. Y is equal to y of c plus y of p, where y of c represents the complementary solution, the solution of the homogeneous equation, and y of p is the particular solution. Let's start off by finding the value of y of c first. Now, to do that, we first check if the given differential equation is in standard form. This means that the coefficient of the second derivative is equal to 1. In our case, the coefficient of the second derivative is already 1. So now we are going to write associated homogeneous equation with r of x is equal to 0. You can notice that it is second order homogeneous equation with the constant coefficients, and we know that the standard solution to such equation is y is equal to e power mx. To find the y prime and y double prime, we're going to be finding the first and the second derivatives. Now, if you're going to be substituting these values in their respective positions, we know that e power mx is common in all three terms, which is going to be factored out. And we also know that e power mx is not equal to 0, as it is a solution of this homogeneous equation. So let's write the auxiliary equation directly. So the roots are real and repeated. Therefore, the general solution, the complementary function, is going to be y is equal to c1 e power 2x plus c2 x e power 2x. This x accounted for the second case where the roots were real and equal. Now we're going to be comparing it with this equation here. And you can notice that the value of y1 is e power 2x, and the value of y2 is x e power 2x. So let's write it down separately. Now that we have found the complementary solution, we are going to find the particular solution using this formula. We know that the values of y1 and y2, which are going to be substituted into their respective positions. To find the value of u1 and u2, we are going to be using the Wronskian method. For that, we'll be finding the Wronskian determinant w by substituting the values of y1 and y2 into the Wronskian matrix. So let's do that. Now to find the value of w1, we are going to be replacing its first column with 0 and f of x, where f of x is the right-hand side of this non-homogeneous differential equation. This one. So the value of f of x is going to be x plus 1 e power 2x. Let's substitute this value here, and let's find its determinant as well. Now that we have found all the determinants, we are going to be using the formulas for the u1 prime and u2 prime. And eventually, we're going to be integrating both sides of each equation to find the values of u1 and u2 respectively. So let's do that. Now that we have found the values of u1 and u2, and we already know the values of y1 and y2, let's substitute it back into the particular solution equation here. And let's write our final expression. Now that we have found y of c and y of p, we can write our final answer as y is equal to y of c plus y of p. Just substituting the values here and here into this form as it is. And this will be giving us our final answer.